Okay, so a more generic rule or application, if you like, of our area under a curve is in actual fact, when we talk about the area under a curve, we normally say between the area that's bound between the curve and the x-axis, okay? A more generic form of that is just an area bound between two curves, okay, where the top function is f of x and the bottom function is g of x, all right? And so the area between those two curves is given by the integral of whatever domain we're talking about, so between a or b and a, of top function minus bottom function. That's all we need to remember, top function minus bottom function. And when we talk about it being the curve and the axis, well, that bottom function is just y equal to 0. So the more specific case is f of x minus 0 because that's what the bottom function is, all right? So again, process, you have to have a graph, which means you might need to find the points of intersection between the graphs and then try to determine which function is on top, which one's on the bottom, and subtract them in the right order. Let's have a look. So sketch the graphs first. Hint. So quick graph sketch. Y equals 2 minus x, so it's a negative gradient, goes through 2. We'll probably find at that point there is 2 as well. And 4 minus x squared, which is a parabola inverted, which has a intercept at 4. And looks something like that. And a little bit of mental arithmetic will tell us that it goes through that point. So I'm looking for that area there, okay? Let's confirm points of intersection. So 2 minus x is equal to 4 minus x squared. Take x squared and 4 across, I get x squared minus x minus 2 is equal to 0. X minus 2, x plus 1. Does that look right? Yep. Therefore, we get x equal to 2 and x equal to negative 1 of my points of intersection, which seems okay. So that area then is given by the integral between negative 1 and 2 of top function, which is my parabola, subtract the bottom function, which is my straight line, with respect to x. Okay, so it's just that little step there is the only little extra part. So now, between negative 1 and 2 of 4 minus x squared minus 2 plus x, be careful, which is the integral between negative 1 and 2 of negative x squared plus x plus 2 dx, which is equal to, substitute, differentiate, add 1 to the power and divide, add 1 to the power and divide, add 1 to the power and divide, between 2 and 1. And we're going for room. We'll fit that first line here. Substitute 2 in, I get negative 8 on 3 plus 4 on 2 plus 4. Subtract. We've got, actually it should be negative 1, shouldn't it? Negative 1 cubed on 3 plus negative 1 squared, which is a half, minus 2. So we get, let's make it a 6. So we've got 6, so we've got negative 16 plus 12 plus 24 minus, what's that? Minus over 6. So what's that, a third? So it's minus 2 plus 3 minus 12. So we got 36, so we have 20 over 6, subtract negative 14 plus 3 is 11 over 6. which equals 9 on 6, which is, what's that, 3 on 2. Okay, so we can check that on our CAS. Again, we need to have a quick graph sketch. 4 on X, so something like that, and the line Y equals X, which is something like that. Find the area between 1 and 3. So I'm guessing that's going to be 1 there, 1 and 3. So let's have a quick check, find our point of intersection. Let's go 4 on X is equal to X, which means 4 is equal to X squared, equals plus or minus 2. So that's actually point there is at the point 2. So what I need is I need between 1 and 3. So there's the point 1. So it's that area there. There's the point 3 and that area there. So we've got two distinct sections here. And you notice how in the first section, the top function is my 1 on X curve. And in the second section, the top function is the green function there, the Y equals X curve. So my integral between 1 and 2 of top function minus bottom function plus the integral between 2 and 3 of top function minus bottom function. So, okay, so hopefully you can see how we've got that area split up. So now we can just work out our two separate integrals. So 4 on X is 4 natural log of X minus X to the 2 on 2, evaluated between 2 and 1, plus same antiderivative, except this time I've got X to the 2 on 2 minus 4 natural log of X, evaluated between 2 and 3. Let's come in here. So we get 4 natural log of 2 minus 4 on 2, subtract 4 natural log of 1 minus a half. So that's that integral, plus 3, so I'll get 9 on 2 minus 4 natural log of 3, subtract 4 on 2 minus 4 natural log of 2. So, equals 4 natural log of 2 minus 4 on 2 minus 2. 4 natural log of 1 is 0. Minus a minus is plus a half. Plus 9 on 2 minus 4 natural log of 3 minus 4 on 2, which is minus 2. Minus a minus is a plus. Natural log 2. So let's see if we can be careful with grouping everything together. 4 natural log 2, 4 natural log 2 is 8 natural log of 2. A half plus a half, a half plus 9 on 2 is 5. 5 minus 2 is 3. That's that done. 3 minus 2 is 1. And what does that leave me with? That leaves me with minus 4 natural log 3. So that is our answer. All right, let's put our CAS dumps in here. Okay, so we can see our screen dumps and we can see straight away that I've made a mistake. 9 on 2. 9 on 2. What's going on with 9 on 2? Let's have a look here. So I've had a look and my mistake is here. Yeah. So negative 1 cubed. It should be a negative out the front of that. So negative 1 cubed is negative 1 plus a 1, so it makes it a positive. So I made a couple of mistakes here actually. So that's a positive 2. Plus 3 is 5, minus 12 is negative 7 in here. That top line is negative 7. Minus 7 is plus 7. So I made a complete mess of that. And now we can get our 9 on 2. I'm losing it, boys, I think. So that's that there. And the other one, despite it looking wrong, is probably right. Let's rewrite 8 natural log 2 is the same as 4 natural log 2 squared minus 4 natural log 3 plus 1. So that's the same as 4 natural log of. Subtract common base, we divide. Plus 1, which I do believe is what we should have got. Okay, 1 out of 2. Could have been worse, could have been worse. Let's talk a little bit now about, we won't do that. I think this diagram here is something that's very typical of an exam sort of question, where it's about which function is on top where. So if we want this 1, 2, 3, 4, 5 different, which ones have they gone for? The area between the curves f of x and g of x between a and b. Okay, so let's, with our blue pen, bottom function, which one's the top function here? It's not really telling us, is it? We'll have to work it out. Oh, yes, it is. There's f there. And my little graphic covered up the other one. So the red function is f. So red function, red function, red function, red function. So between A and C1, which is area 1, we have red minus blue, yeah? Which is what we've got. In area 2, between C1 and C2, so it's this whole area, I've got blue minus red, which is what we've got. Area 3, I've got red minus blue. Area 4, between C3 and B, I've got blue minus red. Yeah, so that kind of thing is often a typical example of how we have to try and split up our functions, have a graph of our functions, and works that we're trying to solve. So let's have a look at the last one of these, or the last couple of these. Get it nice and big. So I've gone straight for a Desmos printout here of the graph just to make life a little bit easier for us. I reckon this would be technology active. Although both graphs individually are relatively straightforward to find, just trying to determine whereabouts the graphs intersect is probably a bit harder than, so it doesn't matter if I go out of the line. So you can see the two areas here that we're looking to find, yeah? So really this sort of question is just about, okay, how do you define these limits of integration? So the first one here, the cubic function is on top, so that's the blue function. So let's, whoops, there's my blue function, and my red function is my parabola. So hopefully we can see then this green area here is the integral from, or my limits of integration from -2 to the point of intersection. Let's let x times x minus 3 x plus 2 equal x plus 2 x minus 3. Now we could expand and all those sorts of things. What's actually a bit easier here, we can't just divide both sides by x minus 3 x plus 2. What we do instead is we subtract both sides. So we get equal to 0. So let's take those x minus 3 x plus 2 out as a common factor. and I get x minus 1. So now you can see that my points of intersection are at positive 3 and negative 2, which we knew, and the other one is at x equal to 1, which is the one that I was looking for. Okay, so that means for the green section, from negative 2 to positive 1 of top function, which is the blue function, x times x minus 3, x plus 2, subtract the bottom function, which is in red, x plus 2, x minus 3 dx, plus the integral from negative 1 to positive 3. And instead of writing all that stuff out again, we're going to have top function, which is red, which is defined as g of x, minus bottom function in blue, which happens to be f of x. Yeah, so that's the integral that would find the area for me. So it didn't ask me to work it out, as opposed to question 2. Find the area bound between those two graphs. So again, a quick graph sketch, two straightforward functions. So we'll go sine x in blue. Both of them have the same period. So I know that that's 2 pi, and I know that that's pi. And we'll go black for cos x. And we know that it has the same sort of key points, something like that. So you can see the area. Find the area of the region closed by the graph between pi on 4 and 5 pi on 4. So I do know that that's pi on 2, that's going to be pi on 4, I would imagine. There's pi, and I reckon that'll be 3 pi on 4, but we should confirm, shouldn't we? We can't just assume, 5 pi on 4. So let's find our point of intersection. Sine x equal to cos x, which means if I divide both sides by cos x, I get sine x on cos x is equal to 1. So I've got to solve tan x is equal to 1, which means x is equal to pi on 4 and 5 pi on 4, which is what we thought. So in this one, we're just after the region bound by those two functions, between those two areas. So the area we're looking for here is just this area here. Yeah? Let's turn that black line into yellow. So top function is the blue function between 5 pi and 4 and pi on 4. So let's go. What have we done there? I'll just go with red. The integral between pi on 4 and 5 pi on 4 of top function, which is blue. Blue function is sine x, minus bottom function, which is black, which is obviously cos x, dx, which is equal to antiderivative of sine is negative cos x. Antiderivative of cos is positive sine, so that doesn't change, between 5 pi on 4 and pi on 4. I'm going to take that negative sign out the front. So I'm just going to make that a plus, and put a negative out there. Now, instead of that negative sign there, I could have swapped my terminal points around as well. So negative outside of, substitute the first point in. Cos 5 pi on 4 plus sine 5 pi on 4, subtract the whole thing in bracket, cos pi on 4 plus sine pi on 4, negative sign out the front. Now cos of 5 pi on 4, where are we? We're in the third quadrant. where cos is negative. So I get negative root 2 on 2 sine of pi on 5 and 4 minus root 2 on 2 minus cos of pi on 4 is root 2 on 2. Sine of pi on 4 is root 2 on 2. I get negative. So negative 2 root 2 on 2, which is negative root 2 minus root 2, which is negative 2 root 2 with a negative sign out the front, which is equal to 2 root 2. Yeah? So a quick check of that on our CAS.